Hello and welcome back to my channel. I am Upasana Taneja, and in today's video we are going to start U30. This is one of the example of UN group. UN group we are studying in our previous videos. Okay, we have studied what is UN group, how can we construct UN group, how to prove that UN is cyclic or not, and what are subgroups of UN, what are cyclic subgroups, and how can we count other subgroups which are not cyclic and all and everything. So as you all know that we have studied about UN, okay, everything. So in this video we are taking one example. In last video I took example of U11, which was a cyclic group, and today we are taking example of U30, which is not cyclic. And I will start from the basics, that how will we construct U30 group. We will see how can we show this is not cyclic, okay, and we will see what are subgroups of U30. Okay, so from the basic we will start. What is U30? U30, as we know, what is UN? What is UN? Those elements which are less than n and co-prime to n. Those elements comes in UN. Okay, similarly in U30, which elements will come? Which are co-prime to 30 and which are less than 30. Okay, so 1, okay, 2, 3, 4, 5, 6, 7. So what will come? 7, because all these are not co-prime. 2, 3, 4, 5, these are not co-prime to 30. Okay, then 8, 9, 10 we will check, and after 7 it will be 11, and then 13, and then 17, 19, 23 and 29. You can easily check that because all other elements are not prime to 30. Okay, so these are U30's elements. Now I will tell you how to check order of U30. So if you can construct U30, then you can easily tell that number of elements are in this. These are 8 elements. Okay, otherwise if we have a very big number here, then how can we tell? By Phi function, because U30's order of U30 is Phi 30. And how can you calculate Phi 30? It is very simple. Phi of 2 multiply 3 multiply 5. Phi function, you know, we have discussed in our video Phi function, previous video. What is Phi function? Okay, Phi n. I have one video of Phi function in which I have discussed many short tricks on Phi function. Okay, so how can we calculate Phi function? This is PQR. Okay, we will write n here. 30, 1 minus 1 by 2, 1 minus 1 by 3, 1 minus 1 by 5. And when you will solve it, 30 into 1 by 2 into 3 by 2 by 3 into 4 by 5. Okay, and this you will get 8. So by this method also you can solve U30's order. Order of U30 is 8. So you can easily tell its order. Now you know what is U30 group, how can we construct U30 group, okay, and what is its order, you know order also of U30 group. Next we come to how to prove U30 is cyclic. Is U30 cyclic? Okay, so how can we check U30 is cyclic or not? So I told you 3 methods in my previous video, that how can you check UN is cyclic or not. Okay, one of the method was that what do? You see that if n is of the form 1 to 4 p raised to power k and 2 p raised to power k. If n means here n is equal to 30. If 30 is of the form this, either 1, 2, 4, this is obviously not 4, Is it of the form p raised to power k, prime raised to power something, where p is prime, or 2p raised to power k? Okay, if it is of the form this, then we will say this is cyclic. But as we know that it is 2 into 3 into 5, so it is not of any of the form, this or this, so we will say U30 is not cyclic. U30 is not cyclic. And next we come to subgroups. Okay, next is subgroups. When we will make subgroups, or when we will make cyclic subgroups, we will see what is the order of elements also. Okay, and later I will tell you why do we need to see order of elements. Okay, so first of all we will continue with cyclic subgroups. Okay, cyclic subgroups of U30. How do we make cyclic subgroups of U30? For making cyclic subgroups, we need to see these elements. Okay, what is a cyclic subgroup or what is a cyclic group? Any subgroup that is generated by one of the element of U30, okay, is known as cyclic subgroup of U30. That can be generated by these elements. Okay, so one by one we will generate subgroups with these elements. Okay, so first of all we will generate with 1. You can see its order. You have U30, so first of all we will generate with 1. It will be 1 only. What do we need to do? We will operate 1 with 1 time, then we will get 1, then 2 times, then every time we will get 1 only. Okay, so next element is 7. Now we will take 7. Okay, so now we will operate 7 1 times and divide by 30. You will get remainder 7. Now operate 7 2 times. 7 sevens are 49. Okay, then divide by 30. You will get 19. Next, what you will do? You will multiply 7 with 19. Okay, 19 was remainder. Either you can multiply 7 into 7 3 times 7, or the short trick is what you can do. This remainder is 19. Multiply 19 with 7. You will get 133 and then divide by 30. Okay, then you will get remainder 13. Okay, next what do you need to do? Multiply 13 with 7, or you can multiply 7, or you can do 7 raised to power 4, then divide it with 30. Remainder will be then that you will write here. Okay, or what you can do, multiply 13 with 7, you will get 91. Okay, 91, when you will divide 91 by 30, you will get remainder 1. Okay, similarly subgroup generated by 11. Okay, now 121, divide by 30, remainder will be 1. Subgroup generated by 13. Okay, 13. Next is when you will multiply 13 into 13, you will get 169 and divide it by 30, you will get 19. And then 19 into 13, or you can do 13 cube. So 19 into 13 and then divide by 30. The remainder will be 7 and 1. Similarly, you can make with 17. You can try it yourself. If you have any doubt, then you can ask me in comment section. Okay, 19, subgroup generated by 19 is 19 1, and subgroup generated by next element is 23 and next is 29. Subgroup generated by 23 is 23 19 17 1, and subgroup generated by 29 is 29 1. Okay, so these are cyclic subgroups. Okay, now you can tell order of these elements as well. How can you tell the order? What is the order of element? Order of element is how many times we operate 7 that we get identity element. Okay, so as you can see, when you operated 7 4 times, then you got identity. So order of 7 is 4. Okay, so order of 1 is 1, order of 11 is 2 because you operated 11 2 times. Okay, and order of 13 is 4, order of 17 4, order of 19 2, order of 23 4, order of 29 is 2. So you can clearly see this. Okay, and next, one very important short trick that we discussed in our last video was that what can be the order of subgroup? What can be the order of subgroups? What can be the order of subgroups? If we have order of U30 is 8, okay, then we will see divisors of 8. Divisors of 8 are 1 2 4 8. So we can have subgroups of order 1 2 4 and 8. Okay, so here we got subgroups of order 1, we got subgroups of order 2 and subgroups of order 4 as well. Okay, and these were cyclic subgroups of U30. Now if we want to find all subgroups of one U30, then what is the next method to find more subgroups? Okay, and next is how can we find more subgroups of U30? Subgroups of U30. What was that method? Subgroups of U30. I told you that if you need to find subgroups of UN, subgroups of UN, what are subgroups of UN? We denote it like this: UDN, where D is divisor of N. N is 30. So D, we will write D here. So first of all, we will complete this definition. UD of N is equal to X belongs to UN, means those elements of UN such that X mod D is congruent to 1. Means when we divide these elements by D, we should get 1. Then those elements will come in subgroup of UNs. Okay, so first of all we will write a UN here. What was U30? We need to find subgroups of U30. So we will write U30. U30 was this: 1 7 11 13 17 23 29. Okay, and then we will find what is D. D means divisors of 30. Divisors of 30. D. D will be 1 2 3 5 6 10 15 and 30. This will be D. And now we will construct first subgroup. First subgroup is U1 of 30. Okay, because D is 1, first of all we will take 1. Okay, second subgroup is U2 of 30. Third is U3 of 30. Fourth is U5 of 30. Okay, and U6 of 30. U10 of 30. U15 of 30. U30 of 30. And this is very easy to make these subgroups. How? Now you will divide. You will see these elements only. U30's element. Divide by 1 all elements. When you will get remainder 1, you will write here. Okay. So here will only 1 will come here, because all other will give remainder these only. So now divide by 2. When you will divide by 2, then you will get, as these are odd numbers, so you will get U30 only. 1, 7, 11, 13, 17, 19, 23, 29. Okay. Now divide by 3. When you will divide by 3, this will give remainder 1. 7 will give remainder 1. Okay. And then 13 will give remainder 1. And then 19 will give remainder 1. Okay. Then U5 of 30. Now divide by 5. What will give remainder 1? 1 and 11. Okay. Now divide by 6. 1, 7, 13, 19. These will give remainder 1. Now divide by 10. 1 and 11. And divide by 15. You will get 1 only. And 30 you will get 1 only. Okay. So these all are subgroups. And out of these, how many are unique subgroups? 1, 2, 3, 4. Okay, these all are repeat now. 4 unique. Okay. So, and here you got cyclic subgroups. These are cyclic subgroups. This is 1 we had there. Okay. 1, 7, 13, 19 we had there in these subgroups also. So we will not count this. 1, 11 was there. 1 and 11. So we will not count this. This is same 7 and 13. 1, 7, 13, 19. Okay. So this is unique here. 1, 23, 19, 17, because it was not here in these subgroups. Okay. So this is unique, this is unique, and this is unique. This is same. So 3 here. Okay. 3 here and 4 we got here. Okay. 1, 11. Okay. So next we can have subgroups of order 4. We can have subgroups of order 4 and subgroups of order 2, subgroups of order 1, subgroups of order 8. There is only one subgroup of order 8. Okay. And finally, can we make any other subgroup? Yes, we can make one more subgroup. How? We can make one non-cyclic. Can we make non-cyclic subgroups of order 4? Non-cyclic subgroups of order 4 in U30. Of U30 you can say. So for U30 we got subgroups, cyclic subgroups, and these subgroups also we got this. These are 2 improper subgroups. Okay. And then now we will check, can we have non-cyclic subgroup of order 4 in U30? So what is the method of making non-cyclic subgroup? Any subgroup of order 4, A, B, and E. If we have this kind of subgroup of order 4, A, B, and E, and all these elements should be of order 2. So for making a non-cyclic subgroup of order 4, we will see how many elements we have which have order 2. So when we constructed cyclic subgroups, we saw that, what did we see? Order of 11 is 2, order of 19 is 2, and order of 29 is 2. So we have 3 elements of order 2. 3 elements of order 2. Which are these elements? 11, 19 and 23. So these all elements are of order 2. So now we will make subgroup. Okay. Suppose we take 11, A is equal to 11 and B is equal to 19. Okay. Then AB will be equal to, if you will calculate AB, then multiply 19 by 11. 11 9s are 99. 9, 20. Okay, then divide by 30. 36 is a 180. Okay, so you got 29. Okay, and here this was 29 only. Order 2 के elements of order 2 11, 19 and 29. Okay, so 11, 19 and what is AB? AB is 29 and next is identity. So if you will take A this, B this, then you will get C this, means AB this. So either of this, if you will take A this, B this, then you will get C this. So you can take any element, you will get this subgroup only. So you got one more subgroup which was not here. This is 129, 129, 19, 11. This subgroup. This is non-cyclic subgroup. Okay, and you got these cyclic subgroups, unique cyclic subgroups here. Okay, and you got these subgroups as well, out of which this was cyclic, this was cyclic, this was cyclic. Only this is improper subgroup. Okay, so this is not cyclic because U30 is not cyclic. This is U30 only, so this is also not cyclic. So we have two non-cyclic subgroups and others are cyclic subgroups. So by this method we see how can we find cyclic subgroups and non-cyclic subgroups. I hope you understood this, that what is U30. If you are having any case of UN group, any element, any case, like you are having any example of U30 UN group, then what can you do? You just make U30, see its element, construct U30, check whether it's cyclic or not, and now you can see how can you make subgroups also. Okay, so if you are having small groups like U8, U9, U10, you can easily make. Okay, this will not be lengthy process. But if you are doing such big groups like this, U30 and U20, U25, then you need to do little bit work. Okay, but with practice you can do everything. So if you are liking this, then please subscribe to my channel for more videos of modern algebra and real analysis, differential equations. Please visit my channel and keep watching. Thank you so much.